Alright, welcome to Unit 14, the last unit of the year. In this unit we will look at water as a resource and how water is being conserved and polluted by the world today, and even used. We're going to start off by talking about water usage and what we use water for. So let's get into this. Now, whenever we have a water supply that is overused or is polluted, anyone downstream from that water supply is affected. So, people upstream of the pollution or upstream of the overuse, they still have fresh, clean water. But the people downstream are the ones that are most affected. And according to the World Health Organization, more than 1 billion people lack access to clean, reliable, fresh water. So there are about 7 billion people on the planet, so that's 1 in 7 lack access to clean, reliable sources of fresh water. And they're grouped in specific areas. We don't necessarily have that problem where we are. And because of this, and because of how important water is, fresh water is one of the world's biggest and most pressing environmental problems. Could make water be worth much more than oil or gasoline is worth right now in the future if these shortages continue. If we take a look around the world, water gets used for 3 reasons. These are either residential use, agricultural use, or industrial use. As you can see on this graph, in most countries around the world, alright, Oceania, that's talking about Southeast Asia, the Pacific Islands, and Australia. Agricultural is one of the highest in the most developed parts of the world, North America, Western Europe. You have industrial use being the highest. If you look at the world as a whole, 70% of the water gets used agriculturally, 20% industrially, and about 10% residentially. So it depends on where you are in the world, but agricultural is typically the biggest use of fresh water. That being said, here in North America and over in Europe, mainly because of developed Western Europe, industrial use edges out agricultural use. So, most of the fresh water in the world, like we said, is used agriculturally, and that's used to irrigate crops. Alright, and we'll talk a little bit more later. The use of water is different depending on where in the world you are. Population plays a big role, as well as economic conditions. And then you can kind of see, looking back at that graph, if you think back to it, I think it's on your notes right to the right here, or just above this to the right. Industry is about 19%. Residential use is about 10%. And all of this varies depending on where you are in the world and what the situation is in those countries or continents. If we look at residential water use, yeah, it's the lowest, but it's where a lot of us think of using water. You can see right here in this table where most of the water is used. Alright, if we are looking at this, if we just take a look at indoor use, toilets are number 1. We use more water flushing our toilets than anything else. Followed by washing clothes, showers, and faucets. And then look at this number, 36 liters per person per day from just water leaks alone, which is a huge number. And then this outdoor usage, that takes into account washing cars, watering grass. So all in all, the average person uses about 300 liters of water a day. Alright, a liter's a little bit less than a quart. A little bit more than a quart, sorry. So a liter's a little bit more than a quart. There are like 3.78 liters per gallon. And if you compare an American to somebody from India, somebody in India only uses about 41 liters of water a day. Water is much more available to us and a lot easier to use, a lot easier to have access to. Alright, if we look, half of the residential water uses inside the home are used for drinking and cooking. The rest are used for stuff outside the home, like watering lawns, washing cars, that kind of stuff. So it's important to not overuse water on certain activities. Now, the water we use tends to be potable. Potable water means that it is suitable for drinking. So we gotta take nasty, nasty stuff like mercury and arsenic and lead out of water. Now we can find these in polluted water, but they also can occur naturally in groundwater. So we usually treat the water at a water treatment plant to make it drinkable, make it potable. Alright, if you get water from a stream or a lake, sometimes you might want to boil it first to get rid of any bacteria and stuff. Boiling it won't do anything about mercury, arsenic, or lead, but it will take care of any little living organisms in there. We tend to chlorinate our water to kill off the microorganisms that might cause us harm. And those microorganisms are called pathogens. So it's some kind of virus, microorganism like a bacteria, or some other substance that could cause disease. Alright, we typically find it in water contaminated by sewage or animal feces, and we remove it in water treatment. And there are a lot of methods that we use in water treatment to make it potable, and the most common methods of water treatment use both physical treatment, sorting out things in physical ways, through filtration, sedimentation, stuff like that, and chemical ways. Chlorination would be a chemical way where the chlorine would go in and kill the microorganisms, kill off the pathogens. This is a typical water treatment plant. Alright, you have this picture in your notes, but maybe you want to print the slide to have it better. Alright, right here what we got, so we got the first step is first filtration. So the supply is filtered to remove large organisms and trash, so this kind of keeps fish out if it's in a lake or something. Alright, from there we go in, we mix the water, and we put some alum in, which will like stick to a lot of impurities and bacteria, which then get settled to the bottom of the tank. We then refilter it again in second filtration over layers of a coal filter, which will remove other impurities and keep those flocks from the algum or from the alum away. Chlorine then gets added to prevent bacteria from growing in the water and kills off a lot of the bacteria. We then force the water through gases to release, we force air through the water to release unwanted gases. And finally, we sometimes add sodium compounds or lime to soften or harden the water. We add fluoride to prevent tooth decay, and so add some other stuff, and then it comes out of our tap. So all of this goes into treating water to make it potable, make it drinkable here in the U.S. We'll get to the second big chunk of water use now, and that's industrial water use. About 19% if we look at the entire world. Alright, and a lot of times we use water in industry to manufacture goods, so to make stuff. to get rid of waste, or to generate power. We also use it industrially to kind of cool down nuclear power plants and other power plants. We heat the water and then get the energy from it as it cools, so stuff like that. Those are some industrial uses. Most of the water used in industry is to cool down those power plants. So typically what happens here is we pump in water from a big water source, river, lake, something like that, some kind of large water source, usually a surface water source. Alright, then that water goes into the power plant to where it's the hottest, where the most heat and energy is being generated, and the water gets pumped through pipes to cool off the area where all the heat is being produced. So the water will absorb a lot of heat. Remember, water has a really high specific heat, so it can absorb a lot of heat. And then we pump this water back to its source. Now the big problem with this, and we'll talk about this more in a couple of lectures, is that the water that gets returned is warmer than the source. It's clean, so it can be used again, but it's warmer, which could disrupt the natural ecosystem of the source water. So you kind of got to watch out for that warmer water being reintroduced. It's a form of water pollution called thermal pollution. And like I said, in 2 or 3 lectures, when we start talking about water pollution, we will get to thermal pollution and talk about that a little bit more. Finally, the last part and the most water use, about 2/3 of all water used in the in the world, 67% of the water used in the world, 2/3 of water used in the world is used for agricultural use. So growing plants and everything. So we need to give plants a lot of water to go. However, up to 80% of the water used in agriculture evaporates. So we pump in a bunch of water for the plants, and then an enormous chunk of that water evaporates away into the atmosphere and rejoins the water cycle. So it's not the most effective use of water. If you're losing 80%, and that's a high number, but even if you're losing 50% of the water you add in, if you lose just 50% of the water that you use in agriculture right off the top to evaporation, that is not an efficient process. So maybe there's some way we can do things there, and as we talk about water conservation in Lecture 2, we might see a couple ideas of how to avoid this evaporation loss of water. And the main way we use water in agriculture is irrigation. And that is getting plants water from sources other than rain, other than direct precipitation. So bringing water in from elsewhere, either via aqueducts or spraying them with a hose. Because if you have a garden in your backyard and you spray it with a hose, well, that's a form of irrigation, because that is not a source of direct precipitation. There are many different techniques that are used. Some use shallow ditches. Here in the U.S., we tend to use high-pressured overhead sprinklers. This is inefficient because over half the water that comes out of these sprinklers evaporates right off the bat. I mean, think of that evaporative cooling that we talked about in the water question packet of the last unit, where we watched a little video in most of the classes about releasing little tiny droplets of water into the air and letting them evaporate, which means they absorb heat, and cooling the air. Well, that is what is happening when we're using overhead sprinklers. We're pumping the air full of little water droplets. Tons of them will evaporate. And if they evaporate, the water never reaches the plant's roots. So right off the bat, most of the water, or half of the water you are using to try to water your plants in this way, most of that water is being evaporated back up into the atmosphere. So again, what can we do to make it better? And part of lecture 2 is all about water conservation methods. What can we do to help conserve water? And then lectures 3 and 4 deal with water pollution. So that is it for this part. It was a quick little lecture here. Know that about 2/3 of the water in the world is used on agriculture. Make sure you know that about 20% is used on industrial uses, and then the remaining 10% or so is used for residential uses. Alright, so kind of know that stuff. Know a couple different ways people use water in the residential area. Know that the industrial area uses water mostly in cooling off power plants, but can also be used in producing production of some kind of material, or get used in other parts of industry. And no agricultural use is getting water to the plants, which is usually some form of irrigation. That is it for lecture 1. I hope you have enjoyed it, and if you have any questions, please bring them into class. Have a good night.